Hello everyone, this is Maithili working as Assistant Professor in Department of Chemistry, St.Josephs Arts and Science College for Women, Hosur. Today we will see about this concept of acid and bases. There are three concepts of are there. First one is Arrhenius concept, second one is Bronsted-Lowry concept, third one is Lewis concept. In this Arrhenius concept, some limitations are there. So Bronsted-Lowry concepts came. In Bronsted-Lowry concept also some limitations are there. So Lewis concept came. In Arrhenius concept, we in 19th have got Nobel Prize also. First, if we will see about acid and bases of Arrhenius theory. Arrhenius theory acids. An acid is a compound that contains H plus and produces hydrogen ion H plus when dissolved in water. Example, HCl gives H plus Cl minus. Arrhenius theory bases. A base is a compound that contains OH minus group and produces hydroxide ions. That is OH minus. Then one base dissolved in water. Here we will take example of NaOH. NaOH dissolved in water. NaOH gives Na plus OH minus. Second one is Lewis theory of acid and bases. Lewis acid is a substance that can accept an electron pair to form a covalent bond. That is electron pair acceptor. Lewis base, a substance that can donate an electron pair to form a covalent bond, electron pair donor. That is electron pair donor. This is Lewis theory of acid and bases. Conjugate acid base pair. Conjugate acid base pair differ by only one proton, that is H plus. A conjugate acid is the particle formed when a base gains a proton. A conjugate base is the particle that remains when an acid gives off a proton. Bronsted-Lowry acid and bases. In Bronsted theory of Lowry acid has a proton H plus donor and a Bronsted-Lowry base is the proton H plus acceptor. Here acid means proton donor, base means acceptor H plus acceptor. Acid donate a proton, base that donated proton accepted from acid. This is a proton. State that amphiprotic species can act as the both Bronsted-Lowry acids and bases. Distinction between a pair of species differing by a single proton as a conjugate acid-base pair. Bronsted-Lowry acid and bases. Danish chemist Bronsted and English chemist Lowry independently proposed new definitions for acid and bases. These simply state that acid is hydrogen ion donor. H, that is H plus or proton. Base is the hydrogen ion acceptor. Acid and bases always come in pairs. Example, dissolved in water gives proton to water. Example, HCl plus H2O gives H3O in aqueous medium plus Cl minus in aqueous medium. Next we will see about relative strength of acids. The relative strength of various acids can be compared using Ka. The larger the value of Ka, the stronger the acid. The structure of an acid plays an important role in the determining of strength of an acid. For acid, the general formula Hx, the strength of the acid depends upon the polarity of the Hx bond and the strength of the Hx bond, stability of the conjugate base X minus. Relative strength of binary acids within a group, the strength of an acid increases moving down the group. HCl is stronger than HF within the same period. The strength increases as the electronegativity of element X increases. That is, left to right. HCl is stronger than H2S. Dissociation constant. The strength of an acid depends on its ability to transfer its proton H plus to base to form a conjugate base. When an acid Ha dissolves in water, it transfers its proton to water to form hydronium ion, that is H3O plus and a conjugate base. This equation refers to the dissociation of HI into H plus and A minus applying law of mass action. So, strength of an acid and base is defined as the concentration of H plus ions and OH minus ions respectively and its aqueous solution at room temperature. So, Value of dissociation constant. Both acid and base measures its acid strength and base strength or acidity and basicity respectively. The most common way to represent the dissociation constant by taking minus log 10 of dissociation constant represented as pKa. Here pKa equal to minus log 10. The generalized acid dissociation HA in aqueous medium plus H2O in liquid gives aqueous medium plus H3O plus in aqueous medium. The equilibrium expression would be HKC equal to H3O concentration A concentration divided by HA concentration. The equilibrium constant is called the acid dissociation constant Ka. Ionic product of water Kw. Kw is the ionic product of water. Just because a solution H plus it doesn't necessarily means it's acidic. All aqueous solution will contain H plus and OH minus ion. For an acid solution, H plus less than OH minus. For alkaline solution, H plus greater than OH minus. For neutral solution, H plus equal to OH minus. This is the pH scale. 1 to 7 is the acidic medium, 7 is neutral, 8 to 14 alkaline medium. The pH scale where 0 is the pH of very strong acid, 14 is the pH of very strong base, 7 is a neutral solution either acidic or basic. The pH range from 0 to 14. More acidic equal to lower number, more basic is equal to higher number. pH solution introduction. To find the pH of several common solutions, nothing the range of the pH scale. To study the relation between conjugate pairs of acid and bases, the section of buffers. An acid solution results when the number H plus ion exceeds the number of OH minus ions. When the number of H plus ions equal to OH minus of solution is neutral. Degree of dissociation. The degree of dissociation is defined as the proportion of the substances that is dissociated, and it's usually expressed as decimal. The degree of dissociation is often give the symbol alpha. Degree of dissociation is the fraction of total amount of solute that dissociates into ions. Therefore, it cannot be negative. Dissociation degree are always in the range of 0 to 1. Ion effect. The shift in equilibrium that occurs because of addition of an ion already involved in the equilibrium reaction. Operating degree of dissociation. Natural electrolyte, nature of the solvent, temperature, dilution, presence of other solution. There are two favorite types of buffer solutions: acidic buffer, basic buffer. Acidic buffer NH4OH, basic buffer NH4Cl.